All right, today we're going to do the second half of section 5.3, medians and altitudes of triangles. We are today going to focus on the term altitudes. Now, when you think of the term altitude, what comes to mind?
How high you up are.
Planes. A lot of times planes come to mind. Okay? Here's kind of my poorly designed plane. Now, why do planes come to mind for altitude?
They're up in the air.
Up in the air. So what does the altitude measure for a plane?
How high you up?
Its height. Altitude measures the plane's height to the ground. Now think about it. When I measure the plane's altitude, do I measure at an angle like this to the ground?
No, sir.
No. Height is a what?
Vertical.
Perpendicular segment. Height is measured as a perpendicular segment. So today we're going to talk about altitudes or heights in triangles. Okay, so we're going to talk about the heights in triangles. So here's what we're talking about today. Yesterday, if you recall, we talked about medians and centroids. Remember, medians was from the vertex to the midpoint. And that's what gave us the centroid, or also known as the center of gravity, that perfect balancing point. Today we're going to focus on the altitudes, which give us the orthocenter. So an altitude is a perpendicular segment from a vertex to the opposite side. So for example here, let's say I were to have a triangle like this. An altitude would be something like that. It goes from the vertex to the opposite side, forming a right angle.
And it's not from the corners, it's only
Well, we can go from all three sides and corners, yes. And we're going to, because you have to find the point of intersection. Yes, sir. And again, what's unique about this? It actually gives us what's called the orthocenter. And it's the point of concurrency of the three altitudes of the triangle. So, yesterday, remember I talked about the centroid theorem? So a little review here. Let's say if I told you AH here, if I said AH was 15, what would NH be? 5. How'd you find that?
1/3.
Because it's 1/3, right? Remember, they talked about the 2/3 rule, but we talked about the 1/3 rule because it's always easier to find the short segment first. Okay, great. So here's what we're talking about today now. We're going to talk about the orthocenter within altitudes of triangles. We will be doing a lot of graphing today, so if you do want some graph paper, feel free to grab some. There's some either in the cart right there or up in the cabinet over here. But here's what we're going to look at. If I'm given a triangle, ABC here, for instance, let's look at side BC. If you ever have a vertical line, that's always the easiest one to start with. Why? What is perpendicular to a vertical segment?
horizontal.
A horizontal line, right?
Yeah,
If I'm out, I'm going to go up some more.
Yeah.
So if you think about here, BC, it's easy to find the altitude of BC. Why? Because it's going to be a horizontal segment from A. Thanks, Brockton. So there's our altitude for BC. Everybody does really well on that one because it's a vertical line. Perpendicular has got to be a horizontal line. That makes sense, right?
Yep.
Great. It's the next one now that students struggle. I have two other lines. I got to find one of them. They looked at AC here. Okay, so they're looking at AC. Well, I want to find a line perpendicular to that. So what do I need to do? I need to find the slope. Well, how do I find the slope from A to C? What's another way to think of slope? Rise over run. So if I go from A to C here, does anybody know what my slope is? Anybody? AC, slope? Negative 3/6 or negative 1/2. Now, notice, remember, perpendicular means opposite reciprocal slopes. Okay? So if my slope is negative 1/2, what's the perpendicular slope going to be? Positive 2. So from this highlighted line here, I need to do a slope of 2 from the opposite coordinate. So from B I'm going to go down 2, left 1, down 2, left 1, down 2, left 1, until I get to that line and I draw in the altitude to that side. And then I'm looking for that point of intersection. The intersection is located right there, which is the coordinate 1, 3. So again, what we're focusing on today is we need to be able to find slope, and we need to be able to find perpendicular slope, two things we know how to do already, and then we're going to take that from a coordinate and graph it out. All right? So again, if you look at it, it's stuff we already know how to do. We know how to find slope. We know how to do perpendicular slope. We're just going to now put that into context of altitudes in a triangle on the coordinate plane. So let's look at this one here. Triangle FGH has coordinates F is -3, 1, G is 2, 6, and H is 4, 1. As I look at it, which one is probably the easiest line to start with? Why is FH the easiest one?
It's horizontal.
It's a horizontal line. What's going to be perpendicular to a horizontal line? So does everybody agree? That would be my altitude right there.
Yep.
Right? Vertical line to horizontal line, got to be perpendicular. Okay, great. Now I need to pick one other side. Well, McKenna, which side would you like to deal with? Would you want to work with FG or GH? Let's do FG. Awesome. So I'm going to look at FG here. I need to find the slope. Slope is rise over run. Ken, do you know what the slope of FG is? The slope is 1. So if my slope is 1, what's the perpendicular slope going to be, Kenna? -1. So, from Ty, question?
Okay, so for the FH, you don't have to go in the middle. You have to just go.
No, altitude is perpendicular straight down. Correct. Medians go to the midpoint. Is that what you're thinking of? Yes. It's all the different ones. Altitudes come straight down. It does not have to go to the middle. Okay? Now, slope is -1 there. So if I want to go to this yellow line, which coordinate is opposite of the yellow line? H. So from point H, I'm going to do a slope of -1. Up 1 over 1, up 1 over 1, up 1 over 1. I keep going. And I draw my line. There's my altitude to that coordinate. Now I see they intersect. They intersect with that coordinate right there. What are the coordinates of the intersection? 2, 3 is my answer. Nice job. That is your answer there. Again, always start with your horizontal or vertical lines. Always makes it a lot easier. And then pick one other line, find the slope, find the perpendicular slope, and graph that out. And you're looking for that intersection.
Wait, so did we just do all of those?
Yep, we're done.
Wait, we did every single.
Let's try the next one now. So, triangle DEF. Coordinates D are at 0, 0. E is at 3, 6. And F is at 4, 0. So I'm going to connect my dots. I have D, E, and F. Awesome. D, E, F here. I need to find some altitudes. Which altitude looks like it's probably the easiest, Hannah? Which line looks like it's the easiest to deal with first? Why DF? What type of line is it?
Oh,
It's a horizontal line. So what's perpendicular to a horizontal line, Hannah? A vertical. So from point E, I'm going to come straight down. And there's a right angle right there. So there's an altitude right there. Awesome. Now I need to take one other line. Cole, which line would you like to work with? DE or EF? Let's do DE. Awesome. So Cole, I need to find the slope here. What would the slope of DE be? That's all right. I'll bring it to you. We're going to find the slope of DE. So rise over run.
6/3.
6/3, which simplifies to 2/1. Awesome. So my slope's 2/1. Now I want to find the perpendicular slope. So what's the perpendicular slope of 2/1 going to be? -1/2. So from which coordinate now do I have to come from to go to that line? I come from F. And I'm going to do -1/2. So it's up 1/2, up 1/2. When I do that, I get a line that looks something like that right there. Now, as I look at it, I need to find the intersection. Does anybody see where it is? Lucas. Anyways, so now I need to find the intersection. If you look, it's kind of tough to see because it's on a small triangle. The intersection's right there, which is located at about 3 1/2. It's about 3 1/2.
Does it get any harder than
Not really. All right, let's try number 16 on your own.
Jeez.
So you gotta plot the coordinates. M is at -3, 1. A is at 1, 3. And X is at 3, 1. So here's my triangle. Find the orthocenter here. All right, looks like most of us have it here. Which one is the easiest one to start with first? Yeah, the horizontal line is always the easiest one to start with. So MX, I can draw out my altitude right there. There's the altitude. Next one, a lot of you did AX. That's great. The slope of AX is -1, which means my perpendicular slope is going to be a +1. So I'm going to AX. Which coordinate do I have to use? I have to use coordinate M. So I'm going to go up 1/1, up 1/1. I keep going. When I do that, what do you notice about my intersection? Is it intersecting? No, I have to extend my altitude. There's my intersection right there. That's located at the coordinate 1, 5. And in an obtuse triangle, the altitude is located outside of the triangle. It's kind of unique. Okay, now let's look at another problem. It's kind of unique here. I'll put one up here for you. What if I give you a triangle that looks something like this? Kind of here. First off, what type of triangle is this? It's a right triangle. Great. What's an altitude measure? What's an altitude measure? Anybody? The height, right? Altitude measures the height. Okay. Well, let's think about it here. Let's say I look at this line right here. It's a horizontal line. What's perpendicular to a horizontal line? A vertical line, right? So wouldn't it just be this line right here? Okay. What about this vertical line? What's perpendicular to a vertical line? Hey, wouldn't that be just this line right here? In a right triangle, where's the orthocenter located?
There.
It's located at the right angle. It's kind of unique. So on a right triangle, because you already have two of the heights drawn in there, it is in there already. That is the orthocenter. It's kind of unique. And here's your assignment.